For multiple discriminant analysis, now I'm going to tackle about binary logistic regression analysis. Okay, so learning objectives. After the discussion, listeners will be able to identify the concepts of binary logistic regression. We need to cite example scenarios related to the concept, enumerate assumptions of binary logistic regression, apply SPSS in extracting and knowing the significance of each data. Same thing as what we've done with MDA. We are going to include it as well, no? With the application of SPSS for our topic. So the concept of binary logistic regression, just to give you an idea, something to do with a regression technique, which is being used to assess the strengths of a relationship between one dependent and independent variables, and somehow it helps in predicting value of dependent variable from one or more dependent variable. And also regression analysis helps in predicting how much variance is being accounted in a single response. Could either be dependent variable by a set of independent variables. And we also have to consider linear regression analysis, which would somehow require the outcome or criterion variable to be measured as a continuous variable. However, there may be situations when the researcher would like to predict an outcome that is dichotomous and binary. Just a continuation in such situation, a scholar or a researcher can use binary logistic regression to assess the impact of one or more predictor variables on the outcomes. And also, regression analysis is a method to determine the reason-result relationship of independent variables with dependent variables. And to cite regression predict group members, it has something to do with since logistic regression calculates the probability of success over the probability of failure, the result of the analysis are in a form of an odds ratio. Later on, I will be showing you how to identify that in SPSS because it boils down to identifying from an odds ratio at the end of my discussion. At the same time, logistic regression determines the impact of multiple independent variables which are being laid on and presented simultaneously to predict membership of one or other or two dependent variable categories. So in logistic regression, the expected outcome is represented by 1 while the other is coded as 0. So here are some example scenarios that we can somehow get an idea from. So a researcher may utilize binary logistic regression in the following situation. So say for example, a store would like to assess factors that lead to return, no return of the customers. A college would like to assess admission, admit, or do not admit of students based on age, grade, aptitude of test result. Assess if particular candidate wins and loses on election based on the time spent in um, constituency, previously elected, number of issues resolved. And as an HR researcher, would like to ascertain how factors like experience, years of education, previous salary, university ranking affects the selection of candidate in a job interview. And a scholar would like to predict the choice of bank, which somehow public or private, based on independent variables that includes technology, interest rate, value, added services, perceived risk, reputation, and the others, which I think this would be my example later on in SPSS. So we also have some assumptions, same as MDA, logistic regression with binary independent variable application is also assumption, which logistic regression does not assume a linear relationship between dependent and independent variables. We need also to assume that independent variables need not to be interval, nor normally distributed, nor linearly related, nor equal variance within each other. And homoscedasticity is not required. The error terms, which do not need to be normally distributed, even dependent variables in logistic regression is not being measured on an interval or ratio scale. At the same time, the dependent variable must be dichotomous. There should be two categories for a binary logistic regression. And also, categories which we consider as group, as dependent variable, must be mutually exclusive and exhaustive. A case can only be in one group, and every case must be a member of one of the groups. Larger samples are needed for a linear regression because, of course, maximum coefficient using an ML method or large sample estimates, no, same as with our previous discussion, and at least minimum cases of 50 cases per predictor is recommended. That's according to Field of 2013. And also, Hosmer et al. Of 2013 suggests a minimum sample of at least 10 observation per independent variable in the model, but quotient with a 20 observation per variable should be sought if possible. And Fitzgerald et al. Suggests a minimum of 30 observation per independent variable. All right, so this is a very good example. As you can see, no, this is a data which is being generated in the Microsoft, I know, Excel, in the Microsoft Excel, yeah. And here you can see gender and employment. This is not actually included. The independent variable here is the technology, interest rate, value added, perceived risk, reputation, attractiveness, and perceived cost. And the choices are, okay, 0 is considered as public and 1 is considered as private. Okay? All right, so how are you going to analyze that using our SPSS? So you just have to open and extract the sample data into your SPSS, click on Analyze, click on Regression, and then Binary Logistic. And then, first thing that you're going to do is to put dependent variable into choice, no? So, um, here, you're going to put as well, by the way. Dependent is choice, and here in the independent, it comes with technology, interest rate, value added, perceived risk, reputation, attractiveness, and perceived costs. So you just have to click Hosmer, let show goodness of fit. Okay, that's important. And nothing else to be considered. CI, click CI for 95% confidence interval. And um, then you click OK. All right. So here, once done, you click OK after you've done with manipulating all the options, and you will be able to come up with the different results of which. Okay. So here, when you talk about logistic regression, it has something to do with the case processing summary, which you can see in the result, and also the dependent variable encoding. So what does it imply in terms of case processing summary? So for this particular section, it has something to do with the output, which could somehow showcase the process of summary, which is being highlighting the case, no, which is being induced in the analysis. And this example, we have in here a total of 351 respondents. Now, as you can see, there's 351 respondents based on our extracted sample, and there's a 100% target that it was being done. And here, for the dependent variable encoding, what does this imply? The dependent variable encoding has something to do with the table it shows and the coding for the criterion variable. In this case, those who will choose private sector banks are classified as 1, while those who will not choose private sectors will have to choose or being classified as 0. So then again, 0 is public, 1 is private. Next is the classification of table. What is the implication for the classification of table? You can see here that there are also variables not in the equation. So basically, for this particular next section that is being having an output has something to do with the headed block, no, which is headed block 0, which is the result of the analysis without any of our independent variable used in the model. This will serve just as a baseline later for comparing the model with our predictor variables which are included. Okay, now we do have the goodness of fit statistics, which would somehow help you to determine whether the model adequately describes the data. So here in block 1 method, no, you can see here that mostly it's the significant value, p-value is 0.000. Here you can see omnibus test of model coefficient. This is being used to test the model fit. So if the model is significant, this shows that there is a significant improvement in fit as compared to the null model. Hence, the model is showing actually a good fit, okay? Because the significant value is 0.000. And also the Homer and Lemmy shows test is also a test of model fit. As you can see, no, the significance is 0.000. That means to say that the significant value is less than 0.05. Here, the model adequately fits the data. Hence, there is no difference between the observed and predicted model. And here, this is the contingency table of Hosmer and Lemishow's test. So here you can see that the model adequately fits the data. As we can see, there is no C. You can see the difference between the observed and predicted model. Both values are approximately equal. See, the observed one to expected, no, from 1 to 10, step 1 to 10, no, 20, then expected is 20, 14 is 13. There's no much difference into it. Same as here with the private. 14, 13.9, 20, 20, 25, 22. Very non-significant at all. And here we also have the model summary, which is the Nagel-Kirk R square and also the Cock-and-Snell R square. No, these are just validators which estimates terminated at iteration number 5 because parameter estimates change by less than 0.001. And then the model summary shows pseudo R square. What does pseudo mean? Pseudo means that it is not technically explaining the variation, but they can be used as approximate variation for the criterion variable. Normally here in the Nagel-Kirky R square, it is something to do with the adjusted version of the Cox and Snell R square that adjusts the scale of the statistic to cover the full range of 0 to 1. Okay? And somehow it fits into 0 to 1. So in this case, we can say that 70.7% change in the criterion variable can be accounted to the predictor variable in this particular model. Okay, now the classification table is being predicted here, no? As you can see, the classification table here provides an indication of how well the model is able to predict the correct category once the predictors are added into the study. Now here, we can also compare that with this type of classification table, which shows from the previous table of block O to see how much improvement there is when the predictor values are included in the model. The model would somehow correctly classified, as you can see, the overall percentage of 79.8% of cases overall, sometimes referred to the percentage accuracy in classification or PAC. So in other words, we can say that this is the rate of correct classification if we always predict that the respondent would choose public sector bank particularly. No, specifically, it presents information on the degree to which the observed outcomes are predicted by our own model in here. No? But it's just really not that significant in terms of its in terms of its difference. But somehow people here would like to prefer those that are in the public sector. Now, the variable in equation, this is very important, no? This is something that we have to consider in terms of our interpretation. So here we have to consider the odds is the ratio of probability, okay, where P is being multiplied by A over P multiplied by B, okay? So this table, it shows relationship between predictors and the outcome. So you can see there EXPB, okay? And beta is the predicted change in log odds. So for 1 unit change in predictor, there is an XB, change in the probability of the outcome. And also, the beta coefficients can be negative or positive, as you can see. All right? And the one which is just beside the variables, no? And at the same time, it has a t-value and significance of the t-value associated with each other. And then, so for this, the odds ratio, the probability of falling into the target group is equal to the probability of falling into the non-target group. And when you talk about odds ratio, it's greater than 1, okay? Probability of event occurring. So if this falls into that, probability of falling into the target group is greater to the probability of falling into the non-target group. So somehow we can say that the event is likely to occur. And when you talk about odds ratio, it's lesser than 1, okay? If it's lesser than 1, probability of event occurring decreases. So what does this mean? Probability of falling into the target group is less to the probability of falling into the non-target group. Here in our example, the event is likely to occur, unlikely to occur, because we can say that the odds of the customer choosing private bank offering perceived risk is 2.12 times higher than those that are in the public sector banks, which do not offer perceived risk with a 95% confidence interval. So the important thing about the confidence interval is that it does not cross 1. Both values are greater than 1. This is important. Why? Because values greater than 1 means that as predictor variables, it does increase. So do the odds of. In this case, selecting private bank, values less than 1 means the opposite as the predictor increases, the odds of selecting private bank decreases. Okay? And I think that's it. That ends with my report. Here are my two references coming from the book that Doc Nisa shared, the ebook, and also another one coming from the internet as one of my sources. Thank you very much for listening, and I'm open if there are questions. Thank you.